MSC Software presents Virtual Prototyping Solutions for Automotive Door Seal Manufacturers by Fuad Hafiani, an application engineer at MSC Software Corporation. Narration by Michael Sama. Today, we're going to talk about an effective virtual prototyping solution that will help automotive door seal manufacturers design robust, reliable, and dependable door seals. One of the several problems that door seal manufacturers face today is the constant worry that their door seals, although designed for a specific door frame, might not be able to accommodate for the minor potential deviations that could exist in the door design. This leads to wind noise and water leakage during testing, which in turn renders the door seal ineffective. Therefore, there is the constant desire to design a robust door seal that can handle many situations. There are many variables that affect the performance of a car door seal. Some of these variables are things like potential variability in the door position, minor deviations in the door sheet metal, changes in hinge configurations which further affects door positioning and behavior, effectiveness of the door seal itself, which translates to issues of design such as seal wall thickness, materials, and friction coefficients among the different areas of the door seal itself. Therefore, it becomes clear that one must perform virtual test analyses on the door seal designs and run a design of experiments on these variables to ensure a robust door seal design. Another challenge is to try and speed up these analyses processes while using best practices for setup and performance. This will help the manufacturers churn out design iterations quicker with higher confidence of quality. So how can this be done today? With MSC software, any door seal engineer can execute a template, which would have been authored by an expert analyst, which will then guide this engineer to set up the door seal nonlinear analysis model quickly and properly using SimExpert. The template guides the analyst every step of the way, recommending the best practices of setup, from importing the geometry, to meshing, to defining materials and properties, loads and boundary conditions, and so on. Moreover, it is designed in a way to be a generic template, so it can be used over and over again on different door seal designs. Once the model is set up, MD Nastran's Sol 600 or Sol 400 solutions are used to solve for this nonlinear problem to generate the nonlinear results. More importantly is that this template also prompts the user to select the variables that will be used in the design of experiments. Once the door seal engineer selects his variables such as material coefficients, door position, wall thickness, and others, he continues on to do his DOE study. One can now have the template invoke another application altogether to generate the DOE matrix if desired. In this example, Adams Insight has been used to do that. Once the runs are solved with MD Nastran and the results are viewed in SimExpert, the template is used to automate the generation of a comprehensive report. It will automatically post-process all the results and then snapshot images of the stress contours and deformation plots of the door seal DOE runs and format them with the necessary documentation to render an informative report of the entire DOE study. This now can be shared with other engineers and managers easily so that the appropriate deductions and hence decisions can be made. For example, they could look at the compression load deflection CLD plots, which convey the response of the deformed shape of the seal upon door closing. This analysis is usually performed on different cross-sections around the front and rear doors, header, B-pillar, A-pillar, C-pillar, etc. The door tolerance was used to position the door in the DOE study. The graphs show the CLD curves for min-max wall thickness at nominal, inboard, and outboard positions. An FEA analyst can now look at the report results and conclude whether the design section is robust for certain sheet metal tolerance or not. Usually the CLD target should be met within plus minus 30% at different door positions, inboard, outboard, fore, aft. The contact width and pressure are also important to verify. The best practice is to have at least 3 millimeters contact and 1 psi pressure on the door seal. They can then continue to look at the other plots to make other deductions. Now engineers can either conclude whether this design is good, or they can decide to add more variables to the study, like parameters of the CAD design perhaps, and continue to easily and quickly iterate many times to come up with a quality, robust door seal. Because of the ability to capture best practices with SimExpert templates, leveraging MD Nastran's powerful solver for the nonlinear analyses, great handy tools like Adams Insight, as well as the ability to automate report generation, MSC clearly offers a powerful solution that can help engineers produce reliable analysis results at incomparable speeds to help manufacturers design and produce top-grade competitive products into the marketplace. Thanks for watching. If you'd like to learn more about how to set up and run DOEs quickly and effectively by leveraging SimExpert templates and other applications, please go to www.mscsoftware.com.